Okay, so I'll start again, yeah? Okay, thanks so much, and nice to see you all at GECON 21. So my name is Mohammed, and I'm a PhD student at Seoul National University under Professor Altmann. And we have this work in progress to present today. The topic is towards software compliance, specification, and enforcement using TOSCA. And in this work, we're basically trying to explore the potential of extending TOSCA applications in modeling and enforcing compliance of software and software services. And TOSCA is an OASIS standard, and it stands for Topology and Orchestration Specifications for Cloud Applications. The initial purpose of TOSCA is to automate management and deployment of cloud applications. However, according to OASIS, its applications can be extended beyond what's meant for. So the paper outline is, I'll give an introduction and then describe the objective of this research. And I'll highlight some related work, and I'll discuss the proposed approach and how it works. And finally, I will conclude with the future evaluation of the proposed architecture. So the context we're looking into is the E-type software, which basically automates human and societal activities and involves a real world problem solving. This type of software evolves over time as a response to real world changes. And according to Lemmon's theory of software evolution, which states 18 laws of that govern the evolution of software, as you see in the figure, eventually such evolution leads to increase in complexity, decrease in quality, and challenges in tracking whether changes adhere to policies and compliance requirements. So beside that, distributed development, crowdsourcing, and microservices approach are becoming more common practices nowadays, in which there is a need to provide a clear decoupling of monolithic software applications and enforce non-functional requirements to ensure compliance. So while the evolution of software is primarily focuses on the functional aspects, the non-functional aspects and requirements are also of equal importance to ensure that best practices and security measures are in place. And the gap between compliance experts and software engineers still exists, and it's mostly driven by the big shift to the cloud and the co-evolution of requirements and capabilities, and the continuous changes in policies, industry standards, and legal requirements. Such continuous changes poses some challenges in monitoring whether the overall challenges made in the software adhere to policies and compliance requirements, and also auditing and reporting at different levels of abstractions to different stakeholders. So the objective of this work is to explore how TOSCA addresses compliance modeling of non-functional requirements and enhances the evolution management of software. We propose an approach that brings all stakeholders together and involve them in the design of software blueprints and topology that are compliant with corporate policies and best practices. The aim is to provide a clear separation of concern and enhance visibility and evolution management of software, and more importantly, enhance auditing at all stages of software development lifecycle. So when we talk about the non-functional requirements of software, there is no clear classification between the functional requirements and then non-functional ones, as in most cases there is some overlap between them. And the International Organization for Standardization does not provide any classification between these non-functional and functional ones. Instead, they listed all the 8 requirements, as you see, and within each of these, there are sub-requirements. But there's a study who developed a taxonomy that categorizes non-functional requirements into 3 categories. So this study is by Glintz in 2007. He categorizes, he focuses only on non-functional requirements. He tried to make some taxonomy based on performance requirement and specific quality requirements and constraints. So when it comes to potentials of TOSCA to model these aspects, studies so far have shown that TOSCA can enhance reliability and failover of nodes, improve performance and resource utilization, model security mechanisms and access policies, enhance compatibility, standardization, maintainability, and portability of software. And with the recent updates of TOSCA version 2, there's a big support for policies and triggers in place. The following are related works showing that many studies investigated the use of TOSCA in different areas. And they try to address issues like the gap in IT and law and heterogeneity of cloud service providers, data sharing, and other issues related to security. However, there is more focus on the use of TOSCA for automated deployment and management of applications, with a less attention paid to compliance modeling. The extent to which TOSCA can enhance evolution management of software is not fully explored in the literature. So this is a typical TOSCA service template, and there's an example of web application topology based on TOSCA. As you can see that we can break down the structure of application into its constituent components like nodes, relationships, requirements, capabilities, and so far, and also define policies that we need to enforce. So there is here in the example, the DJ of application, let's say the Django base, should be hosted according to the topology, what it states, should be hosted on an Nginx server and connect to a database of type MySQL, and depends on backend APIs hosted. I mean, all of these are hosted, should be hosted in separate containers that run a container engine of type Docker in this case. And all of these should be hosted in an Ubuntu server. And in some nodes, for example, this one, we can also see that we can configure the minimum number of instance and maximum number so that we can ensure the scaling policy takes place at the provisioning. So this is an example clearly provide the decoupling of typical web application into components and states what's the relationship between them, so that the specifications level, we can constrain such relationship with a strict security policy, can also be modeled at a lower level. So detailed specification of service template can be represented in YAML format, as we can see here. Eventually, we can the orchestrator can take care of the execution of the topology and the policies stated. And according to Oasis, TOSCA can be extended to new types, relationships, policies, and management plans. And this allows functionality of TOSCA orchestrators to be also extended. And here are some compliance of the compliance and functional requirements and the non-functional requirements in which TOSCA can model and enforce, including reliability, security, standardization policy. And as we said, like recently, there's a big shift to policies and triggers, which might, we see more policies to be modeled and recognized by TOSCA orchestrators. So the approach that we propose aims at bringing stakeholders together to collaborate in designing software blueprints in which the final deliverable is a TOSCA-based service template. The approach consists of 3 steps. First, including a collaborative design of the blueprint, and the second is making this blueprint available at the repository for the development and operations team for continuous delivery of services. And finally, auditing and reporting, which is executed by the orchestrator. So this figure depicts the architecture we proposed, and the process starts by designing the software blueprints by the concerned stakeholders. For example, we have like the IT managers and the software architects and compliance experts. And once the design is done, the blueprint is published into a repository to be made available for the development and operations team to work on the artifact in a way that allows continuous delivery of updates and service development. So and any changes, but also the DevOps team have to be will be forced automatically to comply with the blueprint because it's managed by the orchestrator here. So that like any changes that require modification at the topology level have to be reviewed and approved by all stakeholders before proceeding by the DevOps teams. And finally, the most important task is executed by the TOSCA orchestrator, which is enforcing the topology at the production environment. And at the same time, conduct auditing and reporting on a regular basis and based on stakeholders' inquiry. And this reporting can be customized to deliver insights to different levels of insights and different levels of abstraction for different stakeholders. So in conclusion, the approach we proposed leveraged the use of TOSCA to bring stakeholders all together, collaborating in designing compliant blueprint that consider various policies and non-functional aspects while enforcing them at a lower level. And in future work, we consider validation of the proposed architecture at technical and process levels. And this is an initial proposal for validating our work. And for example, at a technical level, we can use a TOSCA modeling tool for modeling the topology, for example, like OpenTOSCA or Alien for Cloud, which are open source based. And then we can parse the and validate the blueprint using a TOSCA parser, which is an OpenStack project. And possible also we can use another if we find some other tool better, or also extend the existing one. And for the proper repository system, we can either use the normal file system, or we can also think about the a blockchain based, so that we can ensure the tracking of changes not committed in like by any stakeholders, unless there's a consensus. And so for the auditing and reporting, we'll implement a proper TOSCA runtime orchestrator, like Wistia York orchestrator or Heat orchestrator. And so this is the first step we conduct technically, and then the next step is at the process level. A case can be developed and with the multiple stakeholders collaborating to simulate the steps of the proposed approach, and evaluate the overall architecture and process, and check for further improvement. So this is the overall my presentation. Thank you so much. And here are a list of references I use. If you have any questions, please, I'll be happy to answer.
Thank you very much, Mohammed. Do we have questions or comments for Mohammed?
So, I mean, I have a question. So yeah. Perhaps this is something for, now he is, I have a here, it's something for you. Process modeling. So what I'm doubtful is about is how to do this process validation, right? If you want to look at this kind of thing, right, where you have the different stakeholders being involved, right, the compliance expert, the IT manager, software architect, and then right on the other hand, you have these compliance enforcer auditor. So, right, I mean, it really depends on those people, right, to do it.
Yes, I was thinking, and when you are presenting, and I had the questions, you are returning me the question.
Exactly.
because I was thinking, okay, you have the process, but how do you know the process is compliant? Because you can think in different ways. You can think in the question is, if you are we did a process, you are more than a process, is you had the skin of the dependencies, and at the same time you are deploying, you need to know in some way the functional requirements are accomplishing. So the question is how to link monitor the non-functional requirements and define some metrics to trigger when some aspect is not accomplished. And I think you need another process it is a kind of process. You need some kind of fault tolerance workflow to correct the non-functional requirements. So it is not all a process. I think really you are not presenting a process; it's more presenting a diagram of dependencies. But I think it is interesting in some way to model in another plan and in another space processes to react when some trigger appear that advise that it is not the non-functional requirements are not correct. I don't know, just because my answer is much a question. I don't really know what do you represent in this graph. Is a process or is is the question? Is a process or is a dependency graph?
It's actually a combination of a process and also an architectural topology. So here we have the people who are designing the blueprint, and then we're pushing into the whole system here, which can be managed and monitored, and then feedback are given to stakeholders in case of violation or on a regular basis. I mean, the main thing is we don't allow the low level, because at the end, at the production level, we have a continuous delivery and updating of features and services. It's ongoing, sometimes like weekly or each month we have new features added to the system. But in some way that we need to make sure that our topology is not messed up with us, because sometimes if we take a look at at this example, we need to make sure that when you say like connects to, let's say the application connects to, all other ports are closed, only some certain ports or maybe some encryption mechanism should be enforced. So my point is the changes in the topology should be handled at a higher level and incorporating all the stakeholders in the design, so that everyone should have should be aware of what's happening at least at the topology level.
Mhm.